Hi folks, welcome to another episode of NYC CNC. This is part 7 of the series on making the punching and drawing dies to make copper bullet jackets. Let's pick up the pace in this episode. Let's get the top half of this bushing bored out to 701, and then let's make our 700 diameter punch so that we can at least see if we can punch out a nice blank. First off, did want to mention some great tips and comments I've received in the comments below, as well as some direct messages and emails from folks. In episode 6, I was disappointed in the surface finish quality when we bored out this hole to 704. It was an odd surface finish, almost like cutting threads, but it didn't match the feed rate of the mill. The tip of our boring bar has a small chip on it, and that's not doing us any favors. So what we're going to do is we're going to try to clean that up here, either on a hone or maybe on the a diamond wheel grinder. I also just bought a piece of W1 that's coming to later today, and what we're going to do is make our own boring bar. That'll be a fun little exercise to see if we can turn it and machine it and then heat treat it and make one. What we want is we want a radius tip. When you're cutting with a sharp tip like this, and that's slightly less than a 90-degree angle, what you're effectively doing is turning incredibly fine pitch threads. And what we want is a radius tip that'll round those out and provide a better surface finish. I don't think that explains what happened here, but it's something we want to get rid of absolutely before we move on. I'll be able to fix it here, I think, and have no problem getting our piece here bored out. And remember, this is just a guide bushing, so the surface finish isn't quite as important. Another great tip, you'll remember back in episode 3, I had a little bit of a difficult time getting these pins started, and someone made a great comment, which is when you ream out your holes, you're reaming them out to 1 thou under for a press fit on the pins. But what you should do is take the first 25% of the hole depth or some amount and ream it out to 1 thou over, and that'll let you start your pin, get it in there nice and straight, but won't compromise the integrity of that press fit at all. So really appreciate that tip. Last tip is surface finish and sanding, and there were a lot of comments from folks to use some type of a lubricant to wash away some of your sandpaper debris. One recommendation that seemed to be popular was WD-40. Again, I actually am pretty happy with this surface finish, but that's not to say we can't do better. So I had one last comment. Folks were talking about measuring hole inside diameters, and they mentioned using pin gauges. Pin gauges are great, and here's a set of them. This is a set that runs from 1/4 inch to 1/2 inch. So unfortunately, I don't have pin gauges that will work for the hole diameters we're trying right now. But what this is a set that runs every 1,000th inch step from 1/4 inch up to 1/2. This is the 1/2 inch one here. And you basically use them like a go, no-go gauge, where if this will fit in, but the next one won't, then you know you've got 1/2 inch. And these are ground down to, I think, +0 or -2/10. So pretty darn accurate. These are very expensive if you buy American made, and I will admit these are not American made. I can't justify the cost of those. So if you're willing to buy an Asian import version of these, they're not too expensive, and obviously you can buy individual pieces if you don't want to buy the whole set. Almost forgot, we've got to work on our boring bar here. The fact there's so much weight in the tail of this makes it a little bit tricky to sharpen, in my opinion, these brazed carbide bits. I've been working on it here for a second actually, and what I've found I've been doing is I can watch it and make sure I'm following the right angle and push it along like so. I'll try and do one here where you can see it without my hand in the way. This is, by the way, this was a Christmas present some years ago. I haven't used it that much. A 4-sided hone knife sharpener. I'm using the blue side, which is a 200 grit, and it does seem to be working. You can see the marks from the diamond plate on it, and I can tell I've taken some of that chunk out, but there's a little bit left. So I'm trying to do a combination of removing some material from the top face, as well as not too much from this side, but definitely some from this top angle here to get rid of that ding. I've got most of the nick removed, but now what I want to do is I want to see, I'm not too worried about this top face. I think just because there was enough surface area there, it was easy to grind, and I'm not worried about the relief on it. What I am a little worried about is, or at least curious about, is how well I handled the front face here. So let's add a little bit of Sharpie. We'll let that dry, and then let's run it across the hone and see how it looks. Okay, that's not bad. I did this off camera before, and I had not surprisingly honed more off the left and rightmost side and left a little mound in the center, which is not uncommon given that this is not a very steady way to do this. That actually probably won't really affect the boring performance of the tool, but it's always good to kind of pay attention to what you're doing when you're grinding or honing. Now we can hop over and make some chips. Okay, we've got our part in the lathe. We've got the bottom end sticking out, and the reason I'm doing that is sometimes when you turn with a boring bar, you will end up with a taper in the part. I obviously hope that doesn't happen, but what I care more about is the internal diameter where at the lowest point in this bushing where it's guiding the punch against the copper to be blanked. So I'd rather measure here and care more about that. I also had some questions about what a 4-jaw chuck was. I'm going to do a video after this on some basic lathe operations and some more details about this particular lathe. But in the interim, quickly, a 4-jaw chuck is a misnomer. What I mean when I say a 4-jaw chuck and what most machinists mean is each jaw is independently adjustable. What that lets you do is you can adjust or dial in the part exactly. If this were a typical 3-jaw chuck or a 4-jaw where one screw moved all 4 jaws simultaneously, when you tighten down on that part, it's not going to come back in perfectly true. It may be a 1 thou or 2 thou or 3 thou run out, and that's a big deal in this part. We want to get it dead nuts on. I'm going to do that now on fast forward so you'll see it, but I'm not going to walk through all the detail of it. So now we're within 1 thou, maybe a hair more. I want to improve even on that. So there's our low point. Snug that down. Oops. Okay, we're about on 0 now. So that's the low point. And 0 is our high point. So we'll tighten it a little at 0. Okay, we're within 1/2 of 1,000th, which is sufficient for this, so let's bore. Too funny, as I was getting ready to turn the lathe on, I heard a truck pull up, and sure enough, they just dropped off my little piece of W1 tool steel here, so I thought, do I want to go make that boring bar now? But we've got this all set up, and I'm pretty comfortable with using this boring bar that we just fixed up here, at least for this bushing, which is just a guide hole. So we're going to go ahead with that, but I think what I'll do is make part 8 an episode where we go ahead and turn this into a custom boring bar. Okay, now let's really make some chips. First of all, we can check, it can travel through just fine. Let's get our 0 approximate here. Come up and touch the part. Set that at 0. Now we've got, grab our calculator. We want to get to 0.701. We've got about 0.645. That's 56 thousandths, or divided by 2, it means we need to take 28 thousandths worth of cuts. We're going to go 15 now. That should leave us about 13, which we'll measure up to make sure with our snap gauges as a final pass. We're going to go for it this time, unlike last time where we ran into some problems taking tiny, tiny cuts at the end. So 5, 10, 15. And again, this is just a rough cut. Here we go. Okay, I heard it stop cutting. I can see that we're through. Much better. Oh wow, that's awesome. I'm gonna move the camera so you can see that surface finish. That's really cool. Always rewarding to get a nice finish after you grind a tool. Let's see if you can see that. The camera actually makes it look worse than it is. It's a very nice surface finish. Very, very smooth. Okay, let's snap it. Okay, we're at 7 minus 5 minus 10 minus 15, so that's 685, 84, 83. Okay, looks about like 682. Yep. Okay, so 682, 0.701, 0.682 minus 2 divided by 9.5 thou. Let's go for it this time. So there's the half. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're through. Okay, I'm gonna note my mark on the wheel. We're at 99. I'm gonna come in to 80. Move it out of the way, and then I'm gonna move the crossfeed right back to that mark in case we do need to make a follow-up cut. Don't want to lose the spot. Okay, let's see where we are. I was having problems with my 1-inch mic, and I use that mic all the time, and you get to know your tools after a while if they're temperamental, if you think something's off, and that it seemed fine, but it was reading a thou or two off from my calipers, so I've grabbed another mic and we'll see. I think I may have overshot this by 1 thou. Okay, so this is and I grabbed a 1-inch calibration die, and it matched out perfectly fine on that, which is what's so unusual. Let me get the focus fixed here. Okay. So we wanted 701, 705 for. So that's reading 702.5 or 3. I don't think I'm 703, and this was reading about 2 thou wide, which would mean we may be spot on. But I don't like that. It's really odd to me. So we grab our other calipers, or micrometer here. So there's 710, 705, 43. Well, nope. That's 2 and change there as well. Let's re-snap our hole. I did this off camera for a minute, and I got to 702. 705, 4, 3, 2. Yeah, that's what I got before. So I am going to go ahead and say I overshot it by 1 thou. Not the end of the world, but I need to cut that out. We should be able to hold a thou, no problem here. Let's make the punch. We've got a piece of 1-inch 1144 in here. Got it dialed in. We're going to first take a facing cut, and then we're going to turn it down with an end diameter of 700. What I'm going to do is, so that's 150 thou total cut per side. I want to polish in or sand in the last amount. That's not required for this, but I think it'll be a good practice, a good exercise, since there are going to be some surfaces we do want to have polished and sanded. Okay, I am happy with that. Let's take our cutting passes. Here's a new camera angle. I've got the Manfrotto Magikarp mounted right to the carriage, and let's take a first pass cut of 75 thou and see how that does. My camera stopped recording on me, so I stopped the lathe. Let's try that again. Okay, I'm going to let this cut finish. I've got to move the camera out of the way though so the lens doesn't hit the chuck. That turned great, no problem at all with that depth of cut. I didn't use much cutting fluid toward the end as a suggestion from one of the commenters that you don't really need it. So I'm experimenting, but for you lathe guys out there that run 13-inch or bigger lathes, this is new stuff to me. Curious to see what the debate is. The only thing I didn't like was the part was noticeably hotter, which is practically inconvenient. Plus, I always worry about dimensional tolerances when it gets that hot. So we put our mic on here, and we are at 840, just a hair less. So we get our calculator out. Let's say we want to be 4 thou over to sand, so that's 704. So 0.840 minus 0.704 is 136 thou divided by 2. 68 thou. So we're going to take that in one pass here and then we'll sand. Okay, we're on mark 18, just so I remember. Pull this out, and let's get let's measure and see how we did. Okay, let's see where we are. That's awesome. 704 and a half. Check our vernier. Yep, 704 and a half. Now let's see how much taper we've got. Shouldn't have much, but that's something I haven't done a lot of testing on with this lathe that is new to me. Okay, so we do have half a thou across that 1.5 inches or so. Let's see the max here. Okay, we're about a thou across those 2 inches. So that's not great. Won't be a problem here, but I do need to keep that in mind. Some of that may be from the fact that the workpiece was unsupported. I could center drill this and support it on the end with the tailstock. So now we're going to grab our sandpaper and sand this down to 700 on the dot. I'm going to start with some 100 grit. That's obviously a lot more coarse than the 220 we practiced with, so I'm going to do one strip and take a measurement and see where we are. Okay, still at 704. I may wish I had turned this down closer to 700, maybe a thou or two over, but it's okay, we'll sneak up on it. Okay, I did 3 passes with that 100 grit, and man, I've only shaved a few tenths off of it. So lesson learned. Let's come in here and let's take another cut of about a thou and a half per side if we can to get down to say 701. Yeah, I'm not really even cutting now. Let's stop and measure again. We'd only taken about half a thou, so I moved the crossfeed in at 1,000th, so this should be a 2 thou cut. We measure about a half thou over 700 here, and we're about a thou and a half wider out here, but I grabbed the bushing. It just has a slip fit, and it's pretty darn nice. There's really no play. So the good news is we've got a great fit. The bad news is I had to chase it with one final cut, so we're not going to do any more sanding and polishing on this. Okay, it was more for practice, but let's part this off and then let's see what happens. Sorry folks, my camera keeps shutting off on me today and I missed the parting cut here. We're almost done with it, but we're going to part this off and head on over and see how she looks. Okay, let's find our match mark, dimple, like so. Put in our socket head cap screws. Okay. Now let's throw a piece of copper in. Perfect. The punch.